Hi, my name is Mohit Sarveiya. I'm a GDE in Kotlin, and my presentation will be on Micronaut. I want to first, before starting, thank the organizers for and Kotlin London meetup for the opportunity to come back and present. It means a lot to me. Um, so, in this presentation, I'm going to, show you examples of how to build APIs, REST APIs using Micronaut. And I'll show you how coroutines are supported, how to use them with Micronaut, and how to set up database access and setting up retries, and lastly, how to do load balancing. So what is Micronaut? This is a JVM framework, just similar to Ktor or and Spring. And this framework was built by Graham Rose, who is the creator of the Grails framework. And when he built this framework, he applied many of his learnings and his experiences to build this Micronaut framework. And it's a polyglot implementation, meaning when you build your microservice with Micronaut, you could choose Java, Kotlin, or Groovy. So this framework is open source, and it has many benefits. And the benefits that it has is that it's fast it's fast in startup and has a small memory footprint. It also allows you to do meta programming, which I'll show you. And you could, using annotations, set up different, configure like retries and configure different things. So Micronaut, the core architecture is built using RxJava. And so it's reactive, but doesn't enforce it. If you don't want to use the reactive side of Micronaut, you don't have to use that. So it also has ahead of time compilation. So other frameworks, at startup, they will, you do bytecode analysis to learn about the setup of your project. But Micronaut at compile time, like it generates meta information to understand the setup of your project, which makes it really fast at startup. So these are the benefits of using Micronaut. So how do you create a Micronaut project? I want to show you now how to build simple applications using Micronaut. And there are 3 different ways to create a Micronaut project. There's a plugin in IntelliJ. There is also a command line tool that allows you to create different parts of your project. You could also use this Micronaut launch is part of the Micronaut website, and it allows you to configure and specify dependencies that you need, and it will generate a zip file with your project that you could use. So for our examples, I'll show you how to use the command line tool. So the command line tool, you could download it using an SDK manager, and the command line tool has different commands to create scaffolding for different things like controllers, beans, and clients. And I'll show you how to do that. So here's an example of let's look at an example of using this command line tool to build a simple hello world app. So when you download the command line tool, you could do it using, I believe, Brew, and also the SDK manager, and it's called MN, stands short for Micronaut. And it has a command called create app, but there are also different types of other commands. There is a command to create a CLI app or gRPC app or a messaging app. So all these different commands set up just starting code that you would need for that particular type of app. We'll create a very simple REST app. So as I said earlier, this is a polyglot implementation. So you could specify which language you want to use. And by default, it will create a scaffolding in Java, but you could specify Kotlin or Groovy. So, and then lastly, you specify the package name, which is Micronaut app, and it will use that package name and build an app with it. So this is what it builds. It's a very simple structure. So this is a Gradle project that it's going to build. You could specify it to build a Maven project if you want. So it has a Docker file and it has a very simple source set. So in that source set, what you'll see, what it will create for you is an application object. Whichever application you have, obviously you have to start it up at some. You have to have some entry point of your application, and this application object just has a main method that builds your Micronaut app, and then it starts it up. You specify a package name. So this is the starter code that this command creates for you, and we're going to use this and build on top of it. So suppose we want to build a very simple REST API that has a get, and you go to this URI and you give it a name, and what it returns is a greeting, hello, and whatever name you passed it. So this is a very simple example of how do we implement this using Micronaut. So to implement this, what you need to create is a component that's able to handle any requests from the client, any requests to that URI. And this tool, MN, allows you to create has a command called create controller. And what this controller, to use this command, you give it the name of the controller that you want, which is in our case called greeting. And what it will do is create basically two files, the controller class and a test for it. So these two files that it creates for you has some starting code that you could build on top of. For our approach, what we're going to do is what I want to show you how to do TDD, test-driven development. How do you start from the test for our example, and then write our logic in our greetings controller. So let's look at how to write a test for a simple example. So in order to write a test, every test starts with this annotation called Micronaut test. What this annotation does is that it sets up the application object for your unit test. And the next thing that we're going to do is inject an embedded server. So this is what's great about Micronaut. This embedded server will spin up that you could test against in your unit test, and you could do like TDD. It allows you to do TDD with this. So in my test, what I need to do is specify a client. I'm going to create a client that's going to interact with that embedded server, and I need to specify in my client what URI am I going to test? Am I testing against? And I'm testing against this URI here, greet, and the name that I pass in. So what the add client annotation does is that it creates all the scaffolding, the boilerplate code to interact and make this request, to make this client. So Micronaut has dependency injection, and using dependency injection, I'm injecting this greeting client here in my test, and then I have a test in which I'm going to do an assertion that I get what I expect. So I'm going to call this greetings method with the Micronaut string, and then I'm going to do an assertion that it should be equal to greetings Micronaut. So when my client makes a request, that's what I expect my result to be. So I have my test. Now what I need to do is write out the actual logic that this test will run against in my controller. So in order to create a controller, when a controller gets created, it's all annotated with this add controller annotation. And at build time, what that does is generates code to be able to handle the routing to the different methods in your controller. So in this controller, I'm going to handle and add logic to be able to handle this URI, greet, and the name that you pass in. I'll have a method that basically takes that name and it returns a simple string. So greetings and a string template, and greetings and whichever name you pass in. So this is a very simple example of a controller. And I can run my test against, when I run my test against this, it will pass. So what I have done, so the great thing on Micronaut is that you could do even really easy to do test-driven development. So when I run this, I can run this in my browser, and by hitting this URL. So the port is always defaults to 8080, and I could hit that URI, and then I'll get a response back as I expected. So that was a very simple example of creating a Micronaut project using a command line tool. A very simple example of just a hello world example of creating a controller and unit testing it. So let's build on top of this knowledge and look at how to use coroutines. So coroutines are so Micronaut has support for Kotlin coroutines, and you could utilize these different things in your controller. You could have suspending methods. You could also create your own scopes. You could specify that a specific method in the controller should utilize some dispatcher. And you could also build reactive APIs in your controller, have your controller return a flow of items. And let's look at each one of these and how to use it in your controller, in your REST controller. So as I said earlier, the core of Micronaut, when you look at the code, it's built using flowables or RxJava. But there's a bridge that's built on top of it that provides coroutine support. It provides support for using flows, and we'll look at how this bridge is created. So but we just go back to this simple example we had of a controller. How suppose that I wanted to change this to be suspending, although in this example, I'm just returning a single string, you may be doing some IO operations and you want this method to suspend until that's complete. So the Kotlin library provides a keyword called suspend that I could append to this. So and this marks my method suspending. Now the question is, how does Micronaut understand what this suspend keyword is when it encounters it? So when you look underneath the hood in that core architecture Micronaut, what you'll see there is a router. And the router goes through and looks at the different methods that you're using in your controller. It sets up a deferred flowable. So the core architecture of Micronaut is written in Java. And what it does is that it looks at the methods and it checks whether you have a method with the keyword of suspending. And what if you do, it knows how to handle that. And it has a method to be able to execute that type of suspending method. So how does it configure or handle that suspending method? In that use case, what it does is that it sets up a publisher. And what it does is that it looks at your suspending method and then checks, is your suspending method actually returning a type? If you are returning a type, then it creates a publisher from a completable. Thus it creates a flowable by utilizing this approach from a completable. Otherwise, it sets up a completable future. So this is the bridge basically that understands how to handle that suspending method in the core layer of the Micronaut architecture, and it sets up this flowable. So that's how suspending methods are supported. So the other thing is that you may have a scenario. So I had a suspending method in my controller. I may want to execute the logic in there in a separate dispatcher. How do you do that? So what you could do is that in your method in your controller, you could inject an executor service like this, and then you could get a dispatcher from there. So as coroutine dispatcher, an extension provided to you from the coroutine library, and it creates a dispatcher from that. And what I could do is create a coroutine using with context. And with context internally starts a coroutine, creates a scope on the dispatcher that I provide there. with context has the ability, you have the ability in with context to return some the result of some computation. And that's what I could do in there. I could do an IO call and take the results, process them, and return them. And that coroutine will execute on that dispatcher. Everything in there will execute on that dispatcher. So another thing that you may want to do is create your own scope. And you could do so in a number of different ways in your controller. You could create a scope on that dispatcher as a field in your controller and launch coroutines off of that. You could also create a scope using this coroutine scope builder, and this internally creates a scope for you, and everything in the Lambda block will execute on that coroutine. So the other thing that Micronaut supports are flows. So what I showed you so far are just examples of a controller that returns a single value. But you may want to create a stream, a JSON stream, for example. And you may have a use case where you want to emit like at different times depending on your use case. So how do you set that up? So suppose you have a server and you want to emit basically a series of items to the client. And you could create an endpoint like this. Here's a simple example. Suppose you on the back end, you had the stream endpoint the client would hit, gives you a flow. How do you implement that? So to implement that, I have created a method here called stream, and its return type is a flow of int. So here's a very simple example, and where I have a flow of 1, 2, and 3, and I'm calling the on each, there is a delay extension, but it was deprecated. So what this does is that every time something is emitted, before it's emitted, it delays, and then it emits something. So I have set up a simple flow here. And now suppose on the client side, I were to call this URI. What happens? So when I call this on the client side, I'm not going to get any type of data at all. Just going to get this empty JSON object. So the reason why is that there's a piece that I'm missing that's very important to remember, is to add basically a bridge, this module. So the Kotlin Coroutines library has modules for testing, but it also has these reactive modules. And what it's for is for interoperability between coroutines and RxJava. And they have modules for RxJava 2 and version 3, and also reactor modules. So you want to include that as a dependency. So when you include that, and the reason why is that because there is in the core architecture, there is a bridge that hooks for understanding how to work with coroutines and flows. So when I include that, you'll see that, and I run my code, you'll see that I get a chunked response. I get a response, and I get a stream of values now that I expected. And the reason why is that, like, underneath the hood, this right here is the component that makes everything happen. This is a registrar, and what it does is that it basically checks if you're using a flow. If you're using a flow, you'll see right here is this is Java code. So as publisher is an extension on the flow provided to me by the coroutines interop library, and it's calling that method to set up a publisher from this flow, and it's doing React Native flow KT. So it's calling that. It has to call the extension in a static manner because this is Java. So this is right here, the bridge that basically understands how to hook up flows to publishers. So this is how coroutines are supported in Micronaut. If you don't want to use coroutines, you could also just use RxJava if you want. So let's look at now how to set up database access. that's built on top of everything that we learn. So in a real world application, you usually have an API does some CRUD operations in some particular database. So let's look at how to set that up with Micronaut. Suppose we want to build a very simple API. This is an API that could list tasks. That could basically, you could get information about a particular task based on an ID. You could also create a task, do a post request, and the client could send in whatever the description of this task is. You could also update an existing task that you want, and this is a put request. You could also delete a task. So this is a very simple task API. How do you create this, implement this with database access using Micronaut? So in Micronaut, so you usually have you have your server that communicates with some database, and you could have, for example, you could have a middle layer like Hibernate, which is an ORM that you could use that provides an entity manager to be able to interact with your database. And let's look at how to utilize that. Not everyone takes this approach. You could also take other different approaches if you want in terms of interacting with the database layer. You could also just write SQL queries yourself if you want more control. So, first thing that we need to do is to create the task data class. Now, using the command line tool, there is a way to create a bean, and it sets up everything for you. So this is a data class, and it has an ID. Each task has an ID, and it has as a description. So when we create this task, I need to be able to set up a schema for my database, and I could do that using the add entity annotation. And I could say that the table that I want to create is called task, and I want the ID field to be the primary key, and I want it to increment every time that I do an insertion. So I'm using annotations to configure this. What I could also do for the description column is to specify what is nullable or unique, give it a name for it for my database schema. So what I've done so far is specify the task table. And now what I could do is set up a repo to interact with this database. So let's look at how to set up being able to get information from the database of a particular task based on an ID. So I'm going to create a task repository. The repository, I'm going to inject an entity manager, which has an API that allows me to save, create, etc. So if I want to find basically information about a task based on an ID, I could use this method on my entity manager that give me a task type based on an ID. That's very simple. But suppose I want to create a task. In order to create a task based on a given description, I could basically create a task object, and then I could say to my entity manager, persisted, do the IO operation, persist this task on the database. So I could also update a particular task. And this is a good example of how the entity manager supports writing custom SQL queries. So what I could do, basically, given a task ID and a new description, I could create a query. It basically goes into the task table and just searches for a row with a task ID and updates the description column. So I could give this query to my entity manager, and I could set basically all the parameters, task ID and description, and tell it to execute and perform the IO operation. So lastly, suppose I wanted to delete a particular task. I could also do that using the entity manager by using the remove method in my repository. So what I have so far is a very simple repository that knows how to communicate with the database. But I know now I need to create a controller that uses this repo. So I'm going to create a task controller, and I'm going to inject this repository in there. And this annotation controller allows me to specify like a base URL that this controller will handle. It will handle URIs with this starting base task URL. And I could specify using this execute on basically all the work that this controller will do. I want it to run on this executor using the execute on. So suppose I wanted to implement basically getting information, this URI here, getting a task based on an ID. And what I could do is just delegate to my repository to give me basically a particular task based on an ID. So what I could, after that, suppose I wanted to handle requests like the post body from the client. So what I could do in order to handle that is that what the client gives me, the description that the person wants to create a task for, I could encapsulate that into this data class, a command. And then what I could do is that the client for this particular information give me a string, or it could give me an empty string. And on the server, on the client, on the controller, I want to be able to handle basically sending error responses and be able to do validation based on what the client gives me. So, and I could do that in my controller. So the way that I could do that is by setting up constraints. And I could set up a constraint as I did here at field. I want this to be not blank. There are all other types of constraints I could set. I could set like a regex that I want for a particular field. And then I'll mark this data class with intercepted, and which at build time will basically generate the code to be able to, do this validation. So in my controller, I'm going to give this task save command. I'm going to have this command. And there's an annotation that hooks up being able to validate this, this command. So one thing to note here is that with Micronaut at build time, this will generate basically, it will subclass this class and add in logic to do this. The one thing to note here is that you will have to mark this class as open, because in Kotlin, as you know, classes are final by default, or you could use the all open Kotlin compiler plugin. So when you create your project, it actually will add that all open plugin for you. So the way you handle save is that you give it to your repository, the description, it will create it. Now, after the IO operation is done, you want to be able to, you may want to set up the headers and be able to send certain status code or errors. Suppose I want to send a 201 back to the client. So there, Micronaut has an HTTP module that provides you with an API to do this, set status codes, update headers, send errors, etc. So for this, I could use this method, create it, and with this HTTP response, this static method, and pass in this task. What this will do is that when I create a task, it will return me the new task that was created as JSON. I could also delete a task, handle that. So suppose the client gives me a task ID to delete, and I could pass in no content back to the client. There's a method that on the HTTP response object that allows me to specify that. So, so that's a simple way to be able to create a controller that handles, sending back responses to the client, to be able to handle validation also. So if I suppose that, as I'm developing this, I didn't set up my database. And what will happen is that, when you go in about testing this as you're developing, it will use an in-memory cache rather than a database. It knows how to detect whether you have set up a database or not. And you'll see it in the logs. You'll see that if you don't have a database set up, it'll use an H2 dialect. If you had a database like Postgres, it'll just use a dialect for that. So the way you configure which database you want, if you want to do any type of configuration in a Micronaut app, there's a YAML file that's created for you. And inside of that file, you could set up basically, you could change the port, set up whether configure Hibernate, and set up your database sources. Like what I have done here is set up the URL, username, and my driver. So when I call this URL, you'll see is that I get, suppose I want to do a post request and send this description. It will, my controller will send me back what was created on the back end. So I could also get a list of all the tasks that I had created in a JSON array, and you'll see in your controller, like the annotation, get annotation, you could specify like different types of application types if you want also. So now suppose that I made this and I want to quickly be able to test, create a simple client to be able to test this API, similar to what I did in my unit tests. So there's a command line tool to be able to create very quickly a client, simple client, and it basically creates a runnable. And inside of there, you could basically create a client to be able to ingest your API to be able to test it out. And the way you do that is that this tool has this command, create CLI app, and you provide it the language and the package name. And what this will do is create the scaffolding, minimal code that you could use. So inside of the way I could set up my client is in a very similar way to did in my unit test. I have this interface and I want to test. I want to try out this get task URI, or I want to try out being able to save a task. And then this will create all the scaffolding, it will create a client for you that you could then use. So you could inject this client into this runnable and just test it out by running it, calling the get task method, and you'll see the request back. So this is a simple utility to be able to quickly test out, command line utility to be able to test out your API. So in summary, we looked at how to build a very simple REST API. We looked at how to use Micronaut's HTTP request and response API, set up database access, and create a command line client. So the other two things that I want to show you is how to set up circuit breakers, which are a way to be able to do retries, to be able to do backoffs. So there's a possibility when you call a particular method that there's a possibility it throws an exception, and how do you basically retry when that happens? So on the client side, using an annotation called circuit breaker, I could basically set up the number of retries I want to do when that happens. I could set up a delay basically that I want to delay for a certain time before doing a retry. So I could set that up on my client to do 5 attempts in this example and delay for 1 second, before every attempt. So with this annotation, you'll see you could test it out in your command line client on how that functionality works. You'll see it work in your logs. So the last thing I want to talk about is load balancing. So Micronaut has built-in support for load balancing. It supports very different types of load balancers, and you could configure them. So you usually have like multiple servers, and you want to be able to manage the load. And by default, like Micronaut uses round robin strategy, but you could implement any different type of strategies that you want. So to set up load balancing, like one thing that you could do, an example I'll show you is that you could set up, you could configure in your YAML file, application configuration, some console, for example. Console is it's a service that open source that allows you to, it provides load balancing, and you could set up registration for all your when you start up your servers, all your servers will register to this console service. You could configure that in your Micronaut application. So, and you'll see, as you see here, it will register with console. You could also, to be able to use any type of port, you could do. I didn't show this here. You could do port -1 to be able to for it to randomly select a port. So by default, the load balancing strategy would be round robin, but you could inject and configure whichever that load balancing strategy that you want. Micronaut has integrations for different types of services. So that was my presentation. I hope that was helpful to you, to give you a good starting point on using or playing around with Micronaut and building applications with it. So I want to provide you, I'll link out in my slides, some resources. There is a resource, lots of YouTube videos from Graham himself, the creator of Micronaut, and he explains much more in depth on the motivations, and check that out. It's on YouTube. Also, wrote a lot of, gave a lot of talks last year on coroutines. And if you need help with coroutines, or you could check out my talks and blog posts on my blog post, codingwithmohit.com. So the other thing is that if you're looking for coroutine training, if you're looking for training a team, or if you're looking for learning how to test things, I could help out by tailoring a curriculum to help you to learn coroutines and provide one-on-one coaching. I have extensive experience on using coroutines on backend on Android, and please DM me on Twitter, heyitsmohit.com, and be happy for mentoring, and to be happy to help you to learn and use coroutines on your team or individually. So I want to say thank you to the organizers, Enzo, Amar, and everyone. It just means a lot to me to present again here at the Kotlin London meetup, and I hope my presentation was helpful. Thank you.
Great. Thank you, Mohit. So we didn't have any. Oh, we do have a question. Does Micronaut support application profile like Spring Boot app? How would the mock external system dependencies and injection work in testing?
So does Micronaut support application profile? So I'm not 100% sure on that, but you could check out the website, which will have more information. I apologize, I'm not sure if it has that support. How would the mock external work in testing? So when you create your Micronaut application, it will set up all the testing dependencies for you. Yeah, that's if you want more information on that, please in the Kotlin language Slack community, there's a Micronaut Slack channel with Graham. If you have any more questions, please, if you want more information, please feel free to ping that Slack room.